Trigonometry is the branch of mathematics which relates the size of the angles of a triangle to the lengths of the sides of a triangle. At the simplest level, use is made of three trigonometric ratios. These are the sine of the angle, which is abbreviated sinx, and this is said to be sin x, the cosine of the angle, and we abbreviate this cos x, or is said to be cos x, and the tangent of the angle, which is said or abbreviated tanx or tan x. For any angle, the sine or cosine or tangent is a fixed number. These values can be easily gotten from your calculator or from a table. For example, if we wanted to find the sine of 50 degrees, you put it into your calculator, put the angle, press the SIN button, and you should see a value something close to this. If I put in the cosine of say 20 degrees, I would get this value, 0.93969, and some more numbers. And let's say another one, if I put the tan of 40 degrees, I would see on the calculator 0.8390996, and there's some more numbers. Now, we are going to relate these trig ratios to the sides of a right angle triangle as follows. First, we need to give these sides some names. The longest side of the right angle triangle, which is always the side opposite the 90 degree, we are going to call it the hypotenuse. Now, the side opposite to the angle we are concerned with, the x degrees, we're going to give it the name the opposite. And the side next to the angle, not the hypotenuse, but the other side that forms the angle, we're going to call it the adjacent. Now, with this labeling, we can define our three trig ratios. First, let's take the sine of the angle. The sine of the angle x degrees for our triangle here is defined to be the ratio of the opposite side over the hypotenuse. The cosine of the angle is going to be defined to be the ratio of the adjacent over the hypotenuse. The tangent of the angle is the ratio of the opposite side divided by the adjacent. Right, in here we're going to use the trigonometric ratios to find the length of a side. Let us consider the triangle given here on the right. And let us say we want to find the length of x that will satisfy this triangle, such that the hypotenuse is 12 units long and this angle that is opposite to x is 40 degrees. Well, we have to choose an appropriate trig ratio. And since we're dealing with the side that's opposite and we have the hypotenuse, we are going to use sine. So we set up our trig ratio. We say the sine of 40 is equal to x over 12. We now make x the subject. Therefore, x is equal to 12 multiplied by the sine of 40 degrees. Using our calculator, we see that the sine of 40 degrees is 0.642787609. And then I multiply that by 12 and I get the answer to be 7.71345. And so x to 2 decimal places is 7.71 units long. Okay, let's see if we were required to find the length of the side that's marked y, or the length of y. Well, y is adjacent to the angle given, and so since we have the hypotenuse here again, we can use the cosine of the angle to find y. So we write down our trig ratio. The cosine of 40 is equal to the adjacent y over the hypotenuse 12. Again, we make y the subject so that y is equal to 12 times the cosine of 40 degrees. Putting that into our calculator, the cosine of 40 is 0.766044443. And multiply it by 12, we get 9.192533317. But we only want our answer to say 2 decimal places, so y is equal to 9.19 units. Let us consider a third example. In this triangle, we have an angle of 35 degrees, a side of A units in length, and another side of 8 units in length. And let us say we want to find the value of A. Well, we see that A is opposite to the angle given, and the 8 is adjacent. And so we can use the tan of 35 to find our value of A. So we write our trig ratio. Tan of 35 is opposite over adjacent. So tan of 35 is equal to A over 8. Once again, I'm going to make A the subject of my expression. So A is equal to 8 times the tan of 35. Using my calculator, the tan of 35 is 0.702075338. And then when I multiply that by 8, 5.60166, and therefore A to 2 decimal places is 5.60 units. So let's recap. We said the sine, so I'm going to put it as a S, is equal to the opposite over the hypotenuse. We also said that the cosine is equal to the opposite. The cosine is equal to the adjacent over the hypotenuse, and the tan is equal to the opposite over the adjacent. This can be remembered in the following way. For the first ratio, we write it as SOH. For the cosine, CAH, and the tangent, TOA, TO, and it is just remembered by this expression, SOH, CAH, TO. Okay, let's do some examples. I'm giving you a right angle triangle. The angle here is 24 degrees. The hypotenuse is 20 units long, and I'm asking you to find L. Using an appropriate trig ratio, find the value of L. I want you to pause the video, do it yourself, and then check your answer after you restart the video. Okay. Well, we have to choose an appropriate ratio, and since we see that L is adjacent to our angle, we're going to use cosine. So the cosine of 24 is equal to the adjacent over the hypotenuse. Therefore, L is equal to 20 times the cosine of 24. Therefore, using my calculator, L is 18.27 units. Okay, in this next example, I have to find the value of y. Once again, I want you to pause the video, attempt to find the value of y by first writing down an appropriate trig ratio and then solving for y. Restart the video and see if you got the right answer. Okay, I notice that I have the side adjacent to the angle, and the side that I want to find is opposite to the angle, and so I will use tan, the ratio of 63, to determine y. So my expression will be tan 63 is equal to y over 15. Make y the subject. Y is equal to 15 times the tan of 63. Using my calculator, the tan of 63, 1.96261.56, and when I multiply it by 15, my answer comes out to 29.439. So to 2 decimal places, 29.44 units. In this next example, we'll find the value of A. And so we have to, again, write down an appropriate trig ratio and then use that to find the value of A. Pause the video, do it yourself, and then restart the video to see if you get the right answer. Okay, we have the hypotenuse, and the side we want to find is opposite my angle, and so I reason that I will use the sine ratio. So the sine of 18 is equal to A over 30. I'll make A the subject. So A is 30 times the sine of 18. Put it into my calculator. Sine of 18, 0.3090169994. I multiply that by 30. I get 9.2705. and therefore to 2 decimal places, A is 9.27 units. Okay, so we'll stop there with this video. The next video we'll look at finding the angle for a given triangle.